Writing chemical formula of compounds. Chemical formula of a compound is a symbolic representation of its atomic constituent. In other words, a chemical formula represents the composition of a molecule in terms of symbols of the element present in that molecule. To write that chemical formula of a compound, one should have prior knowledge of two things: the symbol of the constituent element and the combining capacity of each atom constituting the compound. We know that the combining power or the combining capacity of an atom or an element is called its valency. The number of atoms of other elements with which one atoms of an element combine is decided by that valency of that element. For example, both hydrogen and chlorine have a valency of 1. Therefore, one atoms of hydrogen react with one atom of chlorine to form one molecule of hydrogen chloride. Next, the valency of an ion is equal to the charge on it. While writing that chemical formula, certain rules need to be kept in mind. These rules are given below. The valency or charges on the ions must be balanced. Second, in case of compound consisting of metal and non-metal, the symbol of the metal is written first. For example, in calcium chloride and zinc sulfide, calcium and zinc are metals, so they are written first, whereas chlorine and sulfur are non-metals. Third, in case of compound consisting of polyatomic ions, the polyatomic ions are enclosed in a bracket before writing the number to indicate the ratio. For example, in aluminium sulfate, the polyatomic sulfate ion is enclosed in a bracket before writing. Compounds composed of two different elements are called binary compounds. These are the simplest compounds. While writing that chemical formula for compounds, we first write the constituent elements and their valency, and then cross over the valency of the combining elements. For example, formula of calcium oxide. Symbol calcium Ca and oxygen O, and their valency 2 plus and 2 minus. Thus, the chemical formula of calcium oxide is CaO. Second example, formula of aluminium sulfate. Symbol is Al and sulfate SO4. Then the charges, that is in Al, that is 3 plus and 2 minus for SO4. Then we cross multiply. Thus the formula of aluminium sulfate is Al2SO4 the whole 3. Brackets are used when we have two or more of same ions in a formula. Here the bracket with a subscript 3 indicates that three sulfate groups are joined to two aluminium atoms. Molecular mass and formula unit mass. An atom contains three types of particles, that is electron, proton and neutron. Out of these three particles, the mass of electron is negligible as compared to that of proton and neutron. Thus, the mass of an atom is equal to the mass of total number of neutrons and protons present in it. Molecules are formed when two or more atoms combine chemically in a fixed proportion. The molecular mass of a substance is the sum of atomic masses of all the atoms present in the molecules of that substance. This is also called the relative molecular mass, and its unit is atomic mass unit mu. Hence, to calculate the mass of molecules, that is, to calculate the molecular mass, the mass of all atoms present in it also added. Calculation of molecular mass. Molecular mass of sodium hydroxide and potassium sulfate. Here the chemical formula of sodium hydroxide is NaOH. Atomic mass of sodium is equal to 23 mu. Atomic mass of oxygen, that is 16 mu, and the atomic mass of hydrogen, which is equal to 1 mu. Since sodium hydroxide molecules contain one atom of sodium, one atom of oxygen and one atom of hydrogen, thus the molecular mass of NaOH is equal to 23 plus 16 plus 1, which is equal to 40 mu. Then the second example is the chemical formula of potassium sulfate, that is K2SO4. Atomic mass of potassium 39 mu, atomic mass of sulfur that is 32 mu, and the atomic mass of oxygen which is equal to 16 mu. Since potassium sulfate molecules contain 2 atoms of potassium, 1 atom of sulfur, and 4 atoms of oxygen, the molecular mass of K2SO4 is equal to 39 into 2 plus 39 2 into 1 plus 16 into 4, which is equal to 174 mu. Formula unit and formula unit mass. The term formula unit is used for those substances whose constituent particles are ions. The formula unit mass of a substance is the sum of atomic mass of all the atoms in the formula unit of a compound. For example, calcium oxide has a formula unit CaO. Calculation of formula unit mass. Formula unit mass is calculated in the same way as that molecular mass. Formula unit mass of nitric acid and sodium oxide. The chemical formula of nitric acid is HNO3. Atomic mass of hydrogen 1 mu, atomic mass of nitrogen 14 mu, and the atomic mass of oxygen 60 mu. In one formula unit of HNO3, there are 1 hydrogen atom, 1 nitrogen atom, and 3 oxygen atom. Thus, the formula unit mass of HNO3 is equal to 1 into 1 plus 14 into 1 plus 16 into 3, which is equal to 63 mu. Then the next example for the chemical formula of sodium oxide is Na2O. Atomic mass of sodium 23 mu and the atomic mass of oxygen which is equal to 16 mu. In one formula unit of N2O, there are 2 sodium atoms and 1 oxygen atom. Thus the formula unit mass is equal to 2 into 23 plus 1 into 16, which is equal to 62 mu. The mole concept. One mole of a substance, that is atom, molecules, ions or particles, is that quantity in number having a mass equal to its atomic or molecular mass in grams. One mole of any substance contains 6.022 into 10 to the power 23 particles, atoms, molecules or ions. This means that 1 mole atoms of any substance contains 6.022 into 10 to the power 23 atoms. Similarly, 1 mole molecules of any substance contains 6.022 10 to the power 23 molecules, and 1 mole ions of any substance containing 6.022 into 10 to the power 23 ions. Hence, the mass of the particular substance is fixed. The number 6.022 into 10 to the power 23 is an experimentally obtained value and is known as Avogadro number or Avogadro constant, and it is represented by NO. It is named after that Italian scientist Amedeo Avogadro. 1 mole atoms of an element has a mass equal to the gram atomic mass of that element. Hence, the mass of 1 mole molecules is equal to its molecular mass in grams. The atomic mass of an element is the mass of its atom in atomic mass unit. By taking that same numerical value of atomic mass and changing the unit from mu to g, the mass of 1 mole atoms of that element is obtained. The mass of 1 moles of atom is known as the molar mass of atoms, gram atomic mass or gram atoms. For example, the atomic mass of nitrogen is 14 mu and the gram atomic mass of nitrogen is 14 gram. Similarly, the molecular mass of a substance given the mass of molecules of that substance is atomic mass unit mu. Therefore, as discussed earlier, by taking that same numerical value of that molecular mass and by changing its unit from mu to gram, the mass of 1 mole molecules of that substance can be obtained. Therefore, the mass of 1 mole molecules of any substance is equal to the gram molecular mass of that substance. The relationship between the mole Avogadro number and the mass is summarized as follows. Here one example is given that 1 mole of any particles, that atoms, molecules, ion, which is same as that 6.022 into 10 to the power 23 numbers of atom, molecules and ions in relative mass of those particles in grams. Second, 1 mole of molecules, which is same as that 6.022 into 10 to the power 23 numbers of molecules, and same as that molecular mass in grams. Then 1 mole of atoms, which is the same as that 6.022 into 10 to the power 23 numbers of atom, and same as that atomic mass in grams. Here one examples for that numericals, that calculation of that mass of zero point 0.5 moles of nitrogen gas. The molecular mass of nitrogen is 28 mu, and that mass, which is equal to molar mass into number of moles, and mass is equal to 28 into 0.5, which is equal to 14 gram. Calculation of that number of moles present in 18.06 is into 10 to the power 23 particles of nitrogen, which is equal to 1 mole, which is equal to 6.022 into 10 to the power 23. Number of moles is given by that number of particles divided by that Avogadro number, and that given particles is 18.066 into 10 to the power 23 divided by that Avogadro number, and you get that answer 3. Therefore the number of moles is 3.